Hello everyone, this is Mr. Sia, and in this lesson you are going to learn about transforming absolute value functions. Okay, so before I continue, I'm going to ask you to please pause the video and copy everything that I have here. If you don't have the colors of pens that I have here, that's fine. Just copy what you see, and once you're ready, go ahead and press play to continue. Okay, so let's go ahead and get started. So if you see this A value here, okay, that A value, this value changes points on the table, and when I say table, I mean this table, and I gave you this table on the notes from yesterday, okay, the video that you watched before this one. I'm talking about this table here for the absolute value function. So I just copy that table just to help me and not take too long, okay. So what this A value is going to do to the y values is you're going to multiply. So let's say if this A is 2, then you multiply each y value by 2, okay? And you'll see how this works once I go over a couple of examples. And then if you look at the C value, C and D, they just change the origin. So if you only see the functions such as this one here, okay, this is the absolute value, so this is the parent function, it's at the origin. But if you have a C value inside of the absolute value bars and a D outside, that just means that you're going to shift this point, which is the vertex, either left or right. Okay, so you'll see that also as I go through the examples. So I'm just telling you here, C greater than 0 is going to shift the graph to the right. C less than 0 is going to shift the graph to the left, and this is opposite of intuition. So if you see minus, you might think, oh, it's going to go left, but no, it's going to go right. Okay, if you see plus, it's going to go left. So that's what I mean by saying the opposite of intuition. And also the D value, okay, the D value, if it's greater than 0, then it's going to shift the graph up. If it's less than 0, it's going to shift it down. So this one is just what you think. This one goes with intuition, okay? And also, the absolute value of A, like for example, if the absolute value of A is greater than 1, you have a vertical stretch, okay? But if the absolute value of A is less than 1, which is what I'm saying here, between the values of 1 and 0, so that's less than 1, you have a compression. So we call that a vertical compression or shrink, okay? Now, what happens if A is less than 0? Then in this case, the graph is going to reflect over the x-axis. Along with a vertical stretch or shrink if applicable. So you might see that these will be combined sometimes. So I think I've said too much. What I'm going to do next is I'm going to graph this one here. So this is saying state the transformations with regards to the parent function and graph each function. So again, notice I have just the absolute value of x. So I don't have something like this. There's nothing inside with the absolute value of x. But I do have a minus 3 outside. The question is, what is this minus 3 going to do to the graph? And that's your D value. Okay, so since it's minus 3, I'm just going to state that this function is going to be shifted down 3 units. Okay, and then I'm going to look at the parent function, which is this one here. Okay, and I'm going to shift this graph 3 units down. So then this is the origin, and I'm going to use a plus sign to state the new vertex. So this is 1, this is 1, 2, and 3. I'm going to use a plus sign just to let you know that the vertex was shifted down 3 units. And then I'm going to use this table. So from this point, if I go left 2, meaning I'm taking the absolute value of 2, I'm going to go up 2. Okay? And if I go left 1, which is this one here, then I'm going to go up 1, and there's the other point. So this is the new vertex, and then if I go right 1, this is going to be up 1. If I go right 2, okay, I'm going to go up 2. And then once I have the points, I'm going to connect the points and then sketch the graph. So there's one side, and this is the other side. Now again, this is only asking you to state the transformation and graph each function. Okay, so let's go on to number 2. Now notice here, okay, there is something inside of the absolute value along with the x. So we do have a C value, and in this case the C value is a 2. But remember I said if, again, if this confuses you, just ignore it. Just understand this, okay? Opposite of intuition. So you might think this is going to go left 2, but it's not. It's going to go to the right 2. Okay, so the transformation is right 2 units. So what that means is that I'm going to take this graph from the origin. Again, I'm pointing to the parent function, and then I'm going to move the vertex 2 units to the right, and this will be a plus sign instead of a point. Okay, that's just again me telling you that this graph got shifted. The origin got, the vertex got shifted 2 units to the right. And there is no d value outside of the absolute value, so it's not going to go up or down. So from here, again, using this same table, left 2, up 2, left 1, up 1, right 1, up 1, and then right 2, up 2. And once again, you have those points plotted. You can just go ahead and sketch the graph. Okay, so there's one side, and the other side of the graph. All right, so let's go on to the next example here. So on this one here, and I'm going to try to show you what I have on top of the paper. So I'm going to point out some things here. So notice here you do have a value in front of x, and it is a 2. So in this case, that's your a value. There is nothing inside of the absolute value here with the x, and there is nothing outside of the absolute value. So there is no shift to the left or to the right, and there is no shift up or down. So all that's going to happen here is that this graph is going to have a vertical stretch. Okay, so vertical stretch by a factor of 2. Okay, that's the only transformation. All right, so next, what I'm going to do next is I'm going to copy my table, the one I had, right? So I'm going to have that table here, but now I'm going to have 3 columns instead of 2. One is going to be for the x values, the other one for the original y values, and the third one is for the 2 times the y value. So again, we said this is -2, -1, 0, 1, and 2. Absolute value of -2 is +2. This is +1, 0, 1, and 2. But now we're going to multiply each one of these y values by 2. So then this becomes a 4, because 2 times 2 is 4, 2 times 1 is 2, 2 times 0 is still 0, and 2 times 1, 2, 2 times 2 is 4. So I'm going to use these values, okay, not the ones with the y. So then this is going to be right at the origin, so the vertex didn't move, left, right, right, up or down, okay? And then if I go left 2, 1, 2, I need to go up. Now it's going to be 4. So 1, 2, 3, and 4. And if I go left 1, up 2. And there is that other point. If I go, this is the origin, so that's the point. That's the vertex. And then 1, 2, so right 1, up 2. And then right 2, up 4. Okay, once I have the points, I'm going to connect the points. And I'm going to use this instead. And there is one side, and then I'm going to do the other side, or graph the other side. Okay, now there is the graph of this function. Okay, the next example. On this one here, notice that we have a negative in front of the absolute value. So what does that mean? That means that if this is a is less than 0, then it's going to get reflected over the x-axis, okay, because we have a -1 in front of the absolute value. So then all this is going to do is it's going to reflect, so reflect or reflected over the x-axis. Okay, that's the only transformation here. So for this point, I'm going to do a table, even though I don't think I need to do it, but I'm still going to do it so I can show you what happens here. So I'm going to have my x values and my y values. So this is x, this is y, and this is -y now. Okay, so then I have negative 1y. So this is negative 2, 1, 0, 1, and 2. This is 2, 1, 0, 1, and 2. But now I'm going to change the sign of the y value. So this is negative 2, negative 1, 0, negative 1, and negative 2. And then I'm going to cross these out because I'm not going to use those values. I'm going to use the ones that go with the negative y. Okay, so again, the origin is not going to get shifted up, down, left, or right. So it's going to be here. So this is the origin. And if I go left 2, okay, left 2, now I need to go down 2. If I go left 1, I'm going to go down 1. And right 1, down 1, right 2, down 2. And again, I'm going to connect the points. Okay, I'm going to connect the points here and then sketch the graph. So one side and the other side. Okay, so that's the graph of this function. All right, so let's go on to the next two examples. Okay, so on these two examples, notice that we do have several transformations here. Okay, so from inside of the absolute value bars, I see that I have a +3. So again, that's counterintuitive, which means this is going to go left 3. So I'm going to do that first. So it's going to go left 3. Okay, and then I see that this has a -5 outside of the absolute value bars. So that tells me that it's going to go down. It's going to get shifted down by 5 units. Okay, and then I see that I have a 1/2 in front of the absolute value bars. This is less than 1, which means we are going to have a vertical. I'm just going to say shrink for now. Okay, so vertical shrink by 1/2. Okay, so before I do anything else, I'm going to do the table here. Okay, so I'm going to do the table and then we'll do the graph for this function, applying the transformations. So this is going to be x values, y values, but now since we have a 1/2 in front of the absolute value, that means we're going to take half of the values of y. Okay, so again, -2, -1, 0, 1, and 2. We said this is 2, this is 1, this is 0, this is 1, and this is 2. Now take half of each one of these. Half of 2 is 1, half of 1 is 1/2, half of 0, still 0, half of 1, 1/2 again, and half of 2 is going to be 1. Again, I'm not going to use these values. I'm going to use the ones that are half the value of y. So I'm going to cross them out so I don't get confused. Okay, so next, I'm going to take this graph, the parent function, from the origin, and I'm going to shift it 3 units to the left. So 1, 2, 3, and then down 5 units. So 1, 2, 3, 4, and 5. And I'm going to use a plus sign. And again, this is me telling you that the vertex got shifted. Okay, 3 units left and 5 units down. So then if I go left 2, so 1, 2, I'm going up 1. So there is 1 point. And if I go left 1, then I'm going up half. Okay, and if I go right 1, up 1/2, and if I go right 2, up 1. And there are the points, and then I'm going to connect the points to sketch the graph. Okay. All right, so there you have the graph of this one, and as you can see, it's got a vertical shrink. It's opening up, and then the factor is by a factor of 1/2. All right, so let's go on to the next example. And again, before we do anything, let's see what this is going to do to the graph. So first of all, I see that it has a -2 in front of the absolute value bars, and I see that it has a +1 inside of the absolute value bars, and then a +4 outside. Okay, so let's start with what's inside of the absolute value bars. So in this case, +1, again, don't forget, this is counterintuitive. So where is this going to get shifted horizontally? If you said left 1, you're correct. So the shift is left 1. Okay, that's one transformation. And then this is intuitive. So this is going, it says +4, so that means it's going to go up 4 units. And then we have a 2 in front of the absolute value, and that 2 means that it's going to get a stretch. So it's going to be vertically stretch, or vertical stretch, okay, by 2. So there is 1, 2, 3, and then we have a negative in front of the 2. So that means that it's going to get reflected. Okay, so reflected, or reflect over the x-axis. Okay, so those are the transformations. So this one has 4 transformations. All right, so let's go ahead and start with the graphing of this function. So then left from the origin is going to go left 1 and then up 4. So 1, 2, 3, 4, and again I'm going to use a plus sign here, okay, to let you know that this graph is being shifted, or it has some transformations being applied. And then from here, let's do the table. Okay, so let's do the table here. So I have my x and y values, and then so this will be x, this is y. We have a -2, so it's going to be -2 times y. Okay, so then this is -2, 1, 0, 1, and 2. 2, 1, 0, 1, 2. And this is 2 times -2, that's going to be -4. 2 times -1 is -2. And this is still going to be 0. This is -2. And this is -4. Then I'm going to cross these out so I don't get confused. Okay, so if I go left 2, I'm going to go down 2. So 1, 2, 1, 2, 3, 4. If I go left 1, I'm going to go down 2. So left 2, down 2. And if I go right 2, okay, which is right 1, I'm sorry, if I go right 1, down 2. So there is this point, and then right 2, down 4. So there I have the points that I need, and now I'm ready to sketch the graph. And we're done with this one. Okay. Okay, so I added one more problem here. Okay, and for some reason, when I printed this paper, this didn't go through. So if you're face-to-face, just copy this, or even if you're an online student, just copy the second part, and then we'll go over those 2 problems together. Okay. So number 7 says the parent function f of x equals the absolute value of x is translated 7 units up and 6 units left. So this one looks in the following way. So I'm gonna do the I'm gonna do this here. Okay, so then it's going to be f of x equals, I'm gonna have the x here. I'm going to leave space for now. Okay, and then we do see that we have a c value. Okay, so 12 units up. So this is going to be outside of the absolute value, and this is going to be inside of the absolute value. And it's saying 6 units left. Again, don't forget, this is counterintuitive. So if you see left, that means you're going to add. Okay, so it's going to be plus 6, and then 12 units up. So this one is intuitive, so just the way you think it is, and then plus 12. And that is all this one, that is all we have to do on this one. Okay, so 12 units up and 6 units left. Now for the last problem, this one has several transformations. So the parent function f of x is stretched vertically by a factor of 8. Okay, so again, I'm going to do this. So f of x equals, and again, I'm going to leave some space here. And then x is going to go inside of the absolute value, vertically by a factor of 8. So that means we have an 8 in front of the absolute value. Okay, translate it 7 units down. So this applies outside of the absolute value. So this is, it's saying down. So then it's minus 7 and 3 units right. And again, don't forget, if it's going to the right, that means we are going to be we're going to do it counterintuitive. So this means we're going to subtract 3 units. So minus 3. and reflected over the x-axis. So the only way this is possible is if we have a negative in front of the 8. Okay, and that concludes this lesson. I'll talk to you guys soon. Thank you for watching. Bye-bye.